will do a small recap what we have seen in our previous session. In our last session, we have learned about the concepts of battery pack construction, especially the configuration, cell welding, and the cell selection process. What are the parameters we have to take care when we are designing the battery pack configuration and the overall battery pack configuration itself. All right. So in this session, we will discuss about the cell testing methods and battery charging along with fast charging concept. Okay. So in this week, the learning objective is different types of testing for lithium-ion cells and the battery packs. We're going to see different type of testing methods which actually is required for both cells and the battery pack. Second, different guidelines and the industry standards for testing. Lastly, we will see the fast charging and the concept behind that. Okay. All right. So let's get into our topic, cell testing methods. So the cell testing is very important factor in designing the battery pack, because as we already know that the overall battery pack system itself is a safety critical system. So in that particular case, the cells are very non-linear, and it is very dangerous if it is not properly designed or not handled properly. So in that designing process, it is also necessary after the design or not before the design, the cell testing is done. The cell testing is done both before starting the design process and as well as once the design is completely done. When I say the design, which is the battery pack design. All right. So we can categorize the cell testing into 4 different categories. The first one, aging test. So in this test, we will see how the cell ages with respect to different conditions. In this particular category, aging test, we will perform life cycle test, capacity fade test, and lastly, calendar test. Second category is performance test. In this particular test, we make sure that whatever the cell we have chosen is meeting our performance requirement for the application. So under this performance test, we have 2 different tests. One is dynamic load test. Second is HPPC test. We will dive into deeper in each and every single test in the further slides. We are seeing only the bird's eye view of this cell testing over here. The third one is safety test. In this category, we make sure that all the tests are done under this category in order to ensure the overall safety of the cell under different condition where the actual application is required. Under this particular category, safety tests, we have 4 different type of tests mainly are done. The first one is cell short circuit test. Second, cell overcharge test. Third, cell nail penetration test. And lastly, fire resistance test. Once it is done, we'll move on to the last category, which is mechanical test. We need to also make sure that the mechanical of the structure, whatever we are building for the battery pack, is being tested properly, because we already know that mechanical structure plays a very important role in the battery pack design. If it is punctured or anything like that, then it is going to be a very big difficult issue in order to mitigate the fire which is going to be taking place in the battery pack. So in order to do the tests, we will be having multiple tests under the mechanical test category, which is first one is vibration test. The second test is shock test. And the third one is waterproof test. So these are the different 4 categories. Under the each and every category, we have multiple tests to perform. So we understood now a different type of categories and the type of tests. We also have to understand in what level these tests are being done. Is it done cell level testing or battery pack level testing? When I say cell level testing, which is nothing but individual cell testing. When I say battery pack testing, which is completely done, connected all the cells together and completed with a mechanical enclosure and then testing it. As you can see here in the left hand side, I've given a good selection where you can see which tests are used for individual cells and battery packs level testing, and which tests are done for battery pack level testing. As you can see here, aging test, performance test, and safety tests are done for both individual level cell testing and battery pack level testing. Mechanical test, on the other hand, it is only done for battery pack level testing. When the complete battery pack is done, that's when the mechanical test is done for the battery pack. It is not done for one single cell. So we got the idea about the different type of testings, the categories and the types of testing, and what level all these tests are being done. Let's move on to our first category, and then we will see all the tests under this category in much more detail. The first category is aging test. So under the aging test, we will look into the life cycle test. So the life cycle test is the first test under this aging test. Let's look into how the life cycle test is done and why it is required and where it is being used. So the life cycle test is performed in order to evaluate the cell life cycle is matched to the datasheet or not. As we have already know that the datasheet is only for reference purpose. It's not going to be always accurate based on the cell because of various reasons which we have already discussed in the previous session. So because of this, we will be doing the cycle test. So here we can see the number of cycles. So how it is being checked, the cycle test. So we're going to see the cycle test based on the resistance, internal resistance of the cell, which is going to be in the milliohm. So the more number of internal cell resistance, then the cell is actually aging much faster. The more aging is done. Okay. So as you can see here from this graph, x-axis is number of cycles, okay, which is still 3,500 cycles. And in the y-axis, we can see resistance, internal resistance in milliohms, till 45 milliohms. And the blue color line is discharge of the cell, and the orange color line is charge of the cell. So we already know that the cycle itself means one cycle means one charge and one discharge. So whenever we are doing a life cycle testing, we will do both discharge and charge in one cycle. So that's why you can see two lines over in this graph. So let's take the discharge. As you can see, when you are discharging the cell, you can see with respect to number of cycles done, you can see the resistance in the milliohm, internal resistance of the cell is increasing gradually, and it's going till 25 milliohms. Initially, which was 15 milliohms. So 10 milliohms difference is there, which is huge for a cell. And coming to the charge, so charge is interesting because you have to understand that when we are charging, the internal resistance is going to be always higher. That's why the charging current is going to be always lower than discharge current. We will see this later, but this is the case. The reason why is this because when we are charging, the internal resistance is going to be higher, so the heat is going to be generated more. So that's why the charge current is much lower always compared to the discharge current. You can see the reason very obviously in this particular graph. So the charge is going to be happening here, and the internal resistance is higher in the initial period, which is 20 milliohm. As the number of cycles goes on, which is till 3000 cycles, at 3000 cycle, you can see that it's almost near to 35 milliohm internal resistance. So you get the idea. The more number of cycle we capture the internal resistance and we compare it and we plot the graph and we know what's happening with respect to the life cycle to the cell. So let's see this type of tests, the life cycle tests, are performed by charging and discharging the cell continuously. It is done in different rates. 4C charge and discharge at 80% DOD and 15,000 cycles, where 4C charge and discharge at 100% DOD. So, for example, the interesting part about the life cycle is you can see this particular status in your phone actually. If you are having either Android or iPhone, iOS device, you can actually look into their the life cycle battery of your own phone. So that is pretty interesting. You can figure it out with this particular data whether your battery is good in shape or not. This gives you a idea or good understanding or the foundation to take a decision whether you have to change the battery of your cell phone or not. It's not only for the cell phones, but you can find this particular data even in your Mac OS and as well as for Windows laptop. So if most of them are Windows using, and if you are having a Windows laptop with you, you can do it right away after the session. So you just have to type cmd command prompt in your Windows and use this particular command power cfg / battery report and just enter, and there will be a file which will be saved in your laptop, and you can open that file and check what is the cycle count, how many cycle counts are done, and even what is the health of the battery. So that's again very pretty interesting data where you can see in your laptop. Okay, so let's take this particular real world data over here on this cell life cycle. So here we are seeing the real data of cell cycle data for Tesla. The Tesla cell capacity degrades after 500 cycles. So as you can see, the Tesla cell cycle test is shown in the graph. As you can see here in the y-axis, we are seeing charge ratio percentage, and in the x-axis we are seeing number of cycles which is the cell gone through. As you can see, it is initially 100%. As it is going to 500 cycle, it reduced to 95% capacity, and it is continuously decreasing, so on and so on. You can also see this small deviation, and we have two lines in this graph. That is nothing but difference in temperature. So if you see in the top line where the temperature of the cell is 11 degrees Celsius, and in the bottom line, which is nothing but 21 degrees Celsius. So as you can see, the more temperature it is, the capacity of the particular cell is degrading much faster than when the temperature of the cell is lower. So so from this particular data, we can understand that if the life cycle has been very high, the capacity of the cell decreases. Okay, so this is very important point. You have to note it down. All right. So let's go into the next testing, which is calendar test. So this particular calendar test we have already discussed in our previous sessions, but we will recap it and we'll go a little more detail. Again, this calendar test comes under the aging test category. So in this particular calendar testing, where the life is defined, the calendar life of the cell is defined as the number of hours for which the cell or a battery can be stored in an ideal condition. So you might be asking why this particular test is required. So the answer for that is this particular test is performed in order to evaluate the battery health in ideal condition, and different temperatures. So where exactly we will be, using the cells in ideal scenario. Before going into that, let's look into this particular points about the calendar testing. The cells with different SOC are stored in climate chambers with different temperatures varying from 40 to 60 degrees Celsius. So using these steps, we can easily evaluate the calendar testing. So this is the first point. So you're gonna have a cell in an ideal condition with different SOC stored in a climatic chamber, which is nothing but which has different temperature can be maintained in that particular chamber, varying from 40 degrees Celsius to 60 degrees. And once it is done, the parameters are checked in 6 weeks intervals. And the test will continue for 6 months so that we will have a good amount of data in order to evaluate the calendar test. The parameters are checked under the temperature reference T reference. So once it is done, we will be understanding what exactly is happening in the calendar testing with respect to different cells and with respect to different temperature. Okay, so as we were discussing before, where exactly this ideal scenario is going to be happening. See, when you are buying thousands and thousands of procured cells, which will be stored ultimately in ideal condition in the initial period of time, right? Before and during the entire product development process. So as you can see here, the development process takes very long time in a vehicle level, manufacturing companies. If it is a very small company like 5 to 10% and you're working on a very small project, the timeline won't be that very large, like 2 years or 3 years. But when you take a company which does the complete vehicle from scratch or from in between, where it starts from R&D to vehicle integration, it takes like 1.5 years to 2.5 years very easily. And that is going to be a long time. As you can see, it is from the cell development to the overall vehicle integration, it easily takes 3 to 5 years, as you can see from the graph. It depends upon the company, but yeah, 2.5 years to 5 years is the range. And as you can see here, it starts with R&D. The cell development will happen. Okay, the cell qualification will be going on. We have seen about the qualification, what type of qualifications are done. Once this is going on, the module and pack development will be started already, because we have certain data about the cells. And once it is done, we will be doing in parallel cell modeling and BMS development. Once it is done, we will be completely going for cell validation. Once the cell validation is done, we will be completing the pack validation, and then which will be integrated to vehicle. In fact, even after that, there are a few more steps are there. So you get the idea. So this is going to take a lot of hours. In this particular scenario, when you are procuring a cells, you're going to procure in thousands and thousands of cells, because you're not going to procure very small amount. That's not going to be economically viable. So you're going to procure in a large quantity. So you have to store it before that, right? So cells will be stored in ideal condition for performing multiple iterations of various tests. So that's where the calendar life of the cell is very important. Even after the testing and deployed to the particular vehicle, sometimes the battery pack is not utilized after even deployed to the vehicle. It will be stored for a few months before it is in use. And one more fact is that most of the batteries in defense sector, like for example submarines and so on, sometimes the batteries are put in the shelf for 2 years, 3 years, and so on. So the shelf life should be maintained. So that's where these particular tests comes into very important aspect. So here in the calendar testing, the data sheet information is to increase the calendar life of the cell. So the data sheet would have given already what temperature you have to maintain for the cell. The temperature affects the internal resistance and the impedance of the cell, which in turn decreases the calendar life of the cell. So that is very important to note it down. So temperature plays an important role in maintaining the calendar life of the cells. So let's move on to the next test, which is capacity fade test, which also comes under aging test. So you have to remember here that these tests are done for both individual cell level and as well as battery pack level. Once the battery pack is being designed, these tests will be done all over again in battery pack level. So let's take into look of the capacity fade test. So in capacity fade test, it's a simple test. In fact, so what's exactly we are trying to understand over here in the capacity fade test? We are trying to understand how much capacity is faded, along with a life cycle and the discharge rate. So how are we going to do that? So it's simple that 1 minus capacity T1 divided by capacity T0 into 100. We get the capacity fade in percentage. Here T0 is equal to is nothing but the initial capacity of the battery pack, and the T1 is the final capacity of the battery pack, or the later capacity when we finish the test. All right, let's look into the complete test procedure, and we'll try to understand this particular procedure in much more detail. So here we have 3 steps for the capacity fade testing. So here we have the first step is that these are all discharge rates. The first step discharge rate is 0.3C discharge rate. So we're gonna discharge the battery pack with respect to 0.3C, and once it is completely done, we're gonna fully charge the battery pack now. When it is completely fully charged, we're gonna give a rest for 30 minutes. We are not going to do anything to the battery pack. So when it is in rest, it's an ideal. Once the rest is done, we're gonna discharge again the battery pack full discharge with 0.3. Once completely discharged, we're gonna have it rest, and then again we're gonna fully charge the battery pack with 1C. Once it is done, we're gonna again rest the battery pack for 30 minutes, and again we're going to discharge the battery pack with 0.3C, and again rest for 10 minutes, and we're gonna have all the data now. See, you have to understand one important point carefully, that all these 0.3C, 1C and 2C is all for only for discharge. The charge is always done with 1C. So let's go to the next step, 1C rate. With the same battery pack, we're gonna fully charge the battery pack with 1C, and we're gonna rest the battery pack for 30 minutes. Once it is done, again we're gonna fully discharge with 1C. Once again is done, we're gonna rest the battery pack for 10 minutes. Again charge it with 1C, rest it for 30 minutes, and fully discharge again 1C with 1C, and give 10 minutes rest. Once it is done, again we'll be having a data for the second step completely. And once the 10-minute rest is done, we're gonna fully charge with 1C and rest the battery pack for 30 minutes. We're gonna fully discharge with 2C this time, and we're gonna fully charge again after resting for 10 minutes with 1C. And once it is fully charged, we're gonna rest it for 30 minutes. And once it is rest is done, we're gonna fully discharge with 2C again, and finally we're gonna rest it for 10 minutes. So we have a complete data with initial capacity, what is the initial capacity of the battery pack, and finally what is the capacity after the 2C rate. So once we have this data, we're going to use this particular capacity T1 and T0, and we're going to utilize here, and we're going to find out the capacity fade percentage. From this aspects, we can easily figure out what is the capacity fade percentage for that particular cell or a battery pack. So this capacity fade test is the final test in the aging test category.